Moving on to 7th problem. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to other side bisects the third side. Now moving on to the solution. Theorem 6.1 is nothing but basic proportionality theorem, which states that if a line is drawn parallel to one of the sides of triangle passing through two distinct points of other two sides, then it divides the two sides in the same ratio. So now let us consider a triangle ABC and let E be midpoint of AB, and let us draw EF such that EF is parallel to BC. As E is the midpoint of side AB, we can say that AE is equal to EB. Now, from basic proportionality theorem, if EF is parallel to BC, we can say that AE by EB is equal to AF by FC, which implies we know that AE is equal to EB. That means substituting EB instead of AE by EB is equal to AF by FC, which implies AF by FC is equal to numerator and denominator cancel, so solution will be 1, which implies AF is equal to FC. As AF is equal to FC, we can say that EF bisects side AC. So when line drawn through the midpoint of one side of triangle parallel to other side bisects the third side is right. Moving on to 8th question. Using theorem 6.2, prove that line joining the midpoints of any two sides of triangle is parallel to the third side. Now moving on to the solution. Theorem 6.2 is nothing but converse of basic proportionality theorem, which states that when a line passing through two sides of a triangle divides the two sides in the same ratio, then the line is parallel to third side. So now here let us consider a triangle ABC in which E is the midpoint of AB and F is the midpoint of AC. Now let us join EF. As E is the midpoint of AB, we can say that AE is equal to EB, which implies AE by EB is equal to 1. So let it be as equation number 1. And also F is midpoint of AC, so we can say that AF is equal to FC, which implies AF by FC is equal to 1, which is nothing but equation 2. As equation 1 and equation 2 has the right hand side as 1, we can equate the left hand side, that is AE by EB is equal to AF by FC. Now line EF is dividing AB and AC in the same ratio. So from the statement of Converse of Basic Proportionality Theorem, we can say that EF is parallel to BC. Therefore, line joining midpoints of any two sides of triangle is parallel to the third side is proved. Moving on to the 9th question. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at point O, show that AO by BO is equal to CO by DO. Now moving on to the solution. Given that ABCD is a trapezium in which AB is parallel to DC and diagonals intersect O. So according to this, let us draw a figure. That is trapezium ABCD in which AB is parallel to CD and AC and BD will be our diagonals which intersect at O. Now we are required to prove that AO by BO is equal to CO by DO. In order to prove this, let us join OE such that it is parallel to AB. That comes under construction, that is draw OE parallel to AB. As AB is parallel to CD or DC, we can say that OE is also parallel to DC. Now moving on to the procedure. If we consider the triangle ADB as OE is parallel to AB, and by applying the basic proportionality theorem, here we can say that DE by EA is equal to OD by OB. Secondly, similarly, if we consider the triangle ACD, OE is parallel to DC. From basic proportionality theorem, as OE is parallel to DC, we can say that DE by AE here will be equal to OC by OA. Let it be as equation number 2. And initially we got a relation by taking triangle ADB. Let it be as equation number 1. Now if we observe the equations 1 and equations 2, here on the left hand side DE by AE is common, so we can equate the right hand side, that is OD by DB is equal to OD by OB is equal to OC by OA, which implies let us send OA this side, then it becomes OA by OB is equal to OC by OD. Or OA is nothing but AO by OB is nothing but BO, which is equal to CO by DO. This is our required proof, hence it is proved.